morning, guys. Today we are working on Unit 1, Lesson 9, but we are only going to call this Part 1, and we are only working on page 45 right now. I'm going to write Part 1, okay? Just like we did with Lesson 8. A lot of stuff here, good stuff, but it just takes time. So our learning target today will be the same. I can model with using linear equations, and we're going to pull in some of our background knowledge and some of our real life stuff going on. But really, what it boils down to is we're working on our reasoning skills. So let's jump right into it. There are so many instances where linear models arise in real world scenarios that we cannot cover them all. In this lesson, we want to get more exposure to using linear models to solve problems and to see how they can be used in general if we know the context. Exercise number 1. Martin took 5 quizzes this marking period in math. I'm going to use my blue highlighter. 5 quizzes in math. On the first 3, okay, on the first 3, he scored a 78, a 91, and a 76. If Martin scored a 77 and an 83 on his last 2 quizzes, what was his quiz average? So let's just quickly remind ourselves about how to find an average. So in order to find an average, sometimes it's called a mean. That's the fancier word in math. We add up all of the numbers and then we divide by the number of numbers. I feel like some of you were saying that in your brain before I was saying it out loud. So we're going to take 78 plus 91 plus 76 plus 77 plus 83. And when we get that answer, we're going to divide all of it by the number of quizzes that he took, which this was 5 quizzes. They already told us that, so we don't have to count it up. So let's go ahead and figure out what our numerator would be. Let's add those up. 78. I'm using my calculator. Best tool that Mrs. Brown gave me this year was this calculator. Oh, I'm talking about myself. So I have my sum being 405 over 5. So he basically, in the 5 quizzes, he should have earned how many total points? He could have earned, I should say. Well, each quiz was 100 points. 5 times 100, 500 points. Martin only earned 405 of those. So that means that he can't have a perfect 100, but he can have another grade. So let's take 405 divided by 5, and we get an 81% average for his quiz grades. Okay? Martin earns the same score on his last 2 quizzes. So we're starting over kind of, okay? Like this was our example, and now we're going back down to because this was our if. Now we're going back down to what really happened. So he got these 3 scores. We're going back to reset that, and then we're going again. Martin earns the same score on his last 2 quizzes. Pretty consistent, Martin. When these 2 scores are averaged with the other 3, Martin has a quiz average of 83. So this is important that when those 2 quizzes, and it's also important that the same score on the last 2 quizzes. Let S represent the score. So S is the score that Martin got on those 2 quizzes. Let S equal the score. Algebraically, there you go, people. That means we need the equation and we need the equal sign and all that. Determine the value of S. Algebraically determine the value of S. So here we go. We're going to do the same sort of work. We're going to have 78 plus 91 plus 76. Those are his first 3 quizzes. Plus S plus S. Because he scored 2 more quizzes the same score. But we don't know that score yet. All of that will be divided by 5 once we find out what those values are. And that will equal, it told us his quiz average is an 83. So if I'm looking up here, I hope that he scored higher than these 2 scores because we need to get his average higher than 81. So it needs to be an 83 this time. Anyway, put in that balance beam. Now, interestingly enough, we have to really get rid of that division sign. So the first thing we need to do is undo this division of 5. We need to multiply both sides by 5. Go ahead and write that on your paper. What happens here is that these 5 cancel and we're left with that numerator again. Okay, so how about we figure out what 83 times 5 is, which is 415, and we bring down our numerator, 78 plus 91 plus 76 plus s plus s. Now we should combine our like terms. So let's find out what 78 plus 91 plus 76 is. We've got 245 plus 2s equals 415. I got to be careful with my s's because sometimes that s variable starts to look a little like a 5 for me. Okay, we're getting rid of the 245 points we already know about. He needs to earn 415 points in order to get this score of this average of an 83. So let's subtract those. 415 minus 240 is 245 is 170. I'm just going to bring my work over here. So 2s equals 170 points. So on those 2 quizzes, dividing those points up, he needed to get an 85 on both of those quizzes. So he scored an 85 on the last 2 quizzes. Go, Martin. All right. If you need a break, take a little break, catch up with your notes, and then start the video again. I'm going to keep going. So linear equations involving money can be challenging because decimals are often involved. Yeah, for sure. But this calculator is going to be our best friend, right? Exercise number 2. Ava is looking at the coins in a change jar that contains only dimes and quarters. Probably important that we know it's only dimes and quarters. There are 12 fewer quarters than dimes in the change jar, in the jar. If the jar contains 21 dimes, then determine how much money is in it. Show your calculation. So this is our if. This is like the part of the problem where we're using an example to start to really say, okay, what is this even asking me about? So if the jar contains 21 dimes, then we need to figure out how many quarters are there. It says right here, there are 12 fewer quarters than dimes. So 21 minus 12, we would have 9 quarters. Okay? We want to determine how much money is in the jar. So 21 dimes times 10 cents plus 9 quarters times 25 cents. Okay? We could type all that in, or we could do each part of the multiplication out at a time. We have $2.10. My calculator said 2.1, but I do know that money has to be to the hundredths place, so I need to add that other decimal. Let's do 9 times 0.25, so I get $2.25. So adding those 2 up, we get $4.35. So that's our example. Most likely we're going to use our example to go ahead and make our equation, because sometimes jumping straight to the equation can be a bit difficult. I actually use this strategy when I take quizzes and tests. I start to give myself an example so I can then jump into, give myself like just a whole number example, so then I can jump into the equation a little faster, a little bit better understanding. So let D equal the number of dimes. I'm going to pull that out. Okay, let D equal the number of dimes that the jar contains. If the total of $6.45 is in it, then algebraically find the value of D. Okay, so we know that the number of quarters has to be D minus 12. So this is the number of quarters. You're going to take the dimes, you're going to subtract 12. So that's kind of what we did here. Okay, so let's start off saying that we have D dimes, and we're multiplying that by our 10 cents. Because we have the money value, we have to include the money value with the dimes, with the number of dimes. Plus, instead of writing 9, I have to write the expression D minus 12, and I'm multiplying that by the 25 cents. So we're adding the money that the dimes give us, the value of the money that the dimes give us, and the value of the money that the quarters give us. And that equals $6.45. Okay, we're going to have a lot of work here, but that's okay. We can do this. So this times this, if I want to make that the coefficient, will just give me 0.10d. Okay, 0.10d. I just flipped it around. Now I have to do backwards distribution here. So 0.25 times d is 0.25d. And 0.25 times negative 12, let's see, times negative 12 gives me negative 3. So far, this is my equation. Okay, I'm going to combine my terms here. So 10 cents plus a quarter gives me 35 cents, and I put the d next to it. So I'm basically just handling my coefficients like I normally would, but they're decimals. So all my math is the same. Just the decimals are kind of making it look a little messier, but all the math is the same. So to move this minus 3, I'm going to add 3. And let's see what my calculator gives me. It gives me 0.35d, and then it gives me 9.45. So now, how many sets of 0.35 are in $9.45, right? How many sets of 35 cents are in $9.45? So we're going to divide to find out how many dimes there are. Oh my gosh, can you see this? Okay, here we go. Wow, there are 27 dimes. Wow. Okay. Well, thanks for joining me. We'll keep working on this. You guys are doing a great job. Keep pushing yourselves along.